In this video, we're going to look at basically what chemistry is and then looking at matter, what matter means. So we'll define mass and we'll define weight and we'll look at volume and then the different states that matter exists. And this is kind of our launching point for next week when we start looking at what makes up matter and what elements are and starting to really dig into that periodic table. So chemistry is the study of matter and the changes that matter can undergo in any kind of chemical reaction. So the question obviously, well, what is matter? So matter by definition is any substance that occupies space and has mass. So occupying space, that's volume. So really when we talk about what matter is, it's anything that has mass and anything that has volume. Mass, by definition, is the measure of the quantity of matter an object contains. So how much of matter is in you? So when we talk about weight, we're talking about the force of gravity on your mass, right? So let's say that, I weigh 500 pounds. That's my weight. That's how much force, that's the combination of how much matter is making up my body. So my skin, my bones, my organs, all of that stuff is the matter. And then the force of gravity on that matter. So I'm going to weigh different on different planets because there's going to be different forces of gravity. So for instance, on Mars, there is going to be a lot more gravity, and so I will actually weigh a lot more. On Mercury, there's less gravity, so I'm going to weigh a lot less. However, the amount of mass that my body has, the stuff that makes up my body, that's not going to change in either environment. So mass is a very definite unit. It's how much of something is in something, okay? But weight is something that's going to change depending on the environment that you're in because there's going to be different forces of gravity that push on you. So chemistry is really focused on the mass, how much of something is in an object. Mass can be given different physical and chemical properties. So a physical property is a characteristic or behavior that can be observed or measured without generating new types of matter. So this would include like color, odor, mass, taste, boiling points, density, hardness. These are physical properties. So these are things you can measure that doesn't change the makeup of the matter, okay? Chemical properties are going to be how substances react with other types of matter. So how does one type of matter react with another type of matter? And how it changes when those reactions occur, the different building blocks of the matter. And that would include examples like rusting, burning, tarnishing, explosion, toxicity, those types of things. So just like matter can have physical and chemical properties, chemical reactions can undergo physical and chemical changes as well, or matter can undergo physical and chemical changes. So a physical change is any alteration in the physical appearance of matter, again, without changing any of its chemical identity. So that would be like an ice cube melting, or when you boil water and the water goes from a liquid to a gas and steam. You're just changing the physical characteristics of that water. It's still H2O. It hasn't changed chemically at all. It's just changed its appearance. A chemical change is going to be change in the chemical identity of matter into another substance that's completely chemically different. The best example of this is rust. So, if you have iron, which is going to be matter, okay, it's an element, and then you have oxygen from the air, and when those two things combine, they rearrange their matter to form a completely new substance, which is called iron oxide, better known as rust. This is a chemical change. So you can kind of determine what kind of change based on looking at the composition or the structure of the matter, or specifically looking at atoms, which we're going to talk about next week. Matter can be classified into three different categories. It can be a solid, which means it has a definite shape and volume regardless of location. It can be a liquid, which occupies a definite volume, but it's going to assume the shape of the container that it occupies. So remember, volume is the idea that it takes up space. And then gas, which is going to neither have shape or volume, right? Gas is just kind of floating everywhere. So matter can exist in one of these three states. All elements or matter can probably exist in all three states, but the process to get any particular piece of matter from a solid to a liquid or liquid to a gas is going to vary based on the matter that's involved. So when we talk about water, water is one of the very, very few, if the only chemical compound that can exist very easily in all three states of matter. We can easily go from a solid to a liquid to a gas. Most other elements or compounds or parts of matter, it takes a lot more work to get it from a solid to a liquid or a liquid to a gas. A couple other terms that you should know is the differences between substances and mixtures. So matter can exist in a pure state where it's only made up of one type of atom or one type of substance, or it can be mixed. A substance is pure matter. That's what we refer to as pure matter. So it has a very fixed composition and it won't change from sample to sample. A mixture is when you have two or more substances and all the substances retain their original identities and can be separated. So I always think of a mixture like trail mix, right? You've got peanuts, you've got M&Ms, you've got pieces of pretzels in there. All of those different things, the peanut, the M&M, the pretzel, they're substances, they're pure matter, but we can throw them all into a bowl, mix them all up, and we have trail mix. But if we wanted to, we can separate out each of the peanuts, the M&Ms, and the pretzels if needed. So a homogeneous mixture is going to be where all parts of the mixtures have the same composition and appearance, so it's all mixed together the same. And a heterogeneous mixture is going to be those where the appearance of the mixture is not the same throughout. So you're going to have some kind of separation. Some other key important terms are going to be atoms. These are going to be substances with protons, neutrons, and electrons, and they're going to be the building blocks of matter. And we're going to talk a lot more about atoms, everything you wanted to know about atoms next week. Elements are substances with a very specific type of atom that cannot be broken down into a simpler substance. So these are going to be all the things on the periodic table, which again we're going to talk about in the next couple weeks. A molecule is a group of atoms that are bound together as a unit. They can be two of the same element or two different ones. So like oxygen gas is O2, so it's two oxygens bound together, two oxygen atoms. H2O is a hydrogen and two oxygens, so that would also be a molecule, even though there's two different atoms, hydrogens and oxygens involved. And then compounds are two or more different elements, so they have to be different, that are chemically combined in a fixed ratio. So H2O would be an example of a compound. Also, a compound can be a molecule, right? Because H2O is a molecule, but it's also considered a compound. So a compound is really a specialty molecule because it has two different elements in it versus a molecule which could potentially have two of the same. So that's some basic information about matter. Next week, we're going to dig in really deep to what do elements look like, what do atoms look like, and how do they combine together to start forming molecules and compounds.